Hi, I'm Tom Marks. Welcome to another PlayStation 2 programming live stream. Today, we're going to dive into our graphic synthesizer APIs. We're going to add some new APIs because we worked out why my code wasn't working last stream. We worked out that I was uploading a texture and it was overlapping part of the ZBuffer in VRAM, or somehow corrupting it. And it turned out that to turn the Z depth test on and off for our drawing, I needed to recompile the library. And that's not good. So we're going to make a change to the library which allows us to toggle the Z test without recompiling. That's going to make testing this a lot easier. And that's going to be our first step. Once we have that, we're going to try and make sure that our textures no longer overlap the Z buffer. We're going to make sure the Z buffer is in the correct place and not randomly moved to somewhere else. So, and then if we do that, we have the very noble goal of making things not look bad, because that would be really nice. Currently, everything looks a bit garbage, so we'll have to see. Bobius, good morning. Xlinks, good morning. And I say good morning, it's afternoon for me, but it's probably morning for you, right? Because no one's in the same time zone as me. No one else in the history of the world has ever lived in Australia. So, let's have a quick look at, well, let's go into the directory. And let's have a quick look at what's running at the moment. Last stream, I spent a lot of time, so there's just some random garbage. This tile set kind of sucks, but it's an interesting test. These tiles are nice. You can see that they kind of stretched out, so our aspect ratio isn't correct. So we have to fix that. We've got to fix that. But we have this little game. You can move a little guy around back and forward. This is a lovely tile set that I got off of itch.io. And then as we go across, at a certain point, this message logs, which means we've just unloaded the level chunk that was over to the left. We've loaded in a new level chunk to the right. And we have a world that we can stream in and out. We can stream data in and out. We could have lots of pretty tile sets, and they'll just keep loading and unloading as we move around. And that's the goal. That's what we're really hoping to do with this, to be able to have a big open world that we can move around in that actually takes advantage of some of the quirks of the PlayStation 2's VRAM. For example, these tile sets are being uploaded to VRAM every single frame, because that's what you do on the PlayStation 2. You don't have to, right? But we have the memory bandwidth to do it. And what that means is each one of these chunks, so this section here, which uses one tile set, and then this section over here, which uses a different tile set, it means they can actually use the same region of VRAM for their tile sets, so they don't have to share. They can contend. They can use a full chunk of VRAM each, which means they can have much higher quality detailed tiles and textures drawn. They don't have to share that space. So that's kind of cool. Currently they don't, but they could. That's the goal. That's kind of why I'm doing it like this. I'm experimenting with VRAM management strategies, level streaming strategies, which is going to become really important once we're doing 3D. But there's a problem, and that problem is this tile set in particular. When I upload it, if I have depth tests on when I draw, which I currently don't, if I'm using the Z buffer, which would be nice, even though it's a 2D game, you can still use the Z buffer. Sometimes you want to use Z for like different values. You want to have something that's always in the foreground, something that's always in the background. You don't always want to worry about order of draws. If I turn that Z test on, we'll get a bunch of screen corruption. And we spent about an hour and a half 2 days ago trying to work out why, and it turns out that the Z buffer was being corrupted. Likely the texture is being uploaded into the Z buffer. Cool. So that's something we can work with. We can do that. We can do something with that. But the problem is, as I said, my library doesn't really have APIs for enabling and disabling Z-test. What branch am I in? I'm in main, that's fine. So let's go in and do that. Let's go into our GS header. Let's add some new functions for this. So we'll have GS. The graphic synthesizer state is a global in this library, so we're just going to do it like this. We're going to say GS set Z-test, and we'll just take a mode. And we'll say GS set, not depth test, sorry, set alpha test, the transparency test, how we test if a pixel is rendered through something or not. A test, there are a bunch of different modes for this as well. We can have a look in the graphic synthesizer manual. A test, ATE, here it is. Alpha testing, alpha value of drawing pixel, and the preset standard alpha. So AT, we've got a couple of different fields. ATST, a pixel that failed the alpha test is not controlled completely in drawing. So I'm not entirely sure what this means, but alpha test is another thing we probably want to be able to control, and we want to be able to set to one of these values. All pixels pass. That's an aref. And we have a fail, which tells us what to do with things that fail. Excellent, excellent. So if we draw something that fail, I don't know, I need to work out what pass and fail the transparency test here, but the idea is that we can still update the depth buffer. It's pretty cool. That's pretty cool. You can do really powerful stuff, and you kind of need it because it's a fixed function processor. Cool. So what happens when we set one of these things? If we go into not this gs.c, and we can kind of have a look here, right? So every frame we kind of set this up, and I think we're not gonna allow changing this mid-frame for now. We're just going to accept that we don't do it mid-frame. I think that kind of works, because every single frame, and this is in draw 2D, every single frame start, this is in draw common, not draw 2D, frame start, every single frame we hard code a test. You know what? A test, all that stuff I just said about a test and me not really being sure how it works, that makes me feel like maybe I shouldn't have a function to set it, but definitely z test. Definitely z test, right? We set the z test to whatever the current state thinks the z test method should be. So in other words, if we update it in this file, we have this big global struct. If we update it here, it's just going to work. It's just going to carry through. That's kind of cool. I don't know if this is necessarily the best way to do it, but our graphic synthesizer state kind of is a global. We can't really have two different graphic synthesizer states. It is a hardware component in our system, and I think this is the best way to manage it. I think this is probably the best way to manage it. So what do we have? State, and this is actually a pointer, state z state at state dot oh, we're just forward declaring it, aren't we? Hold on. I misunderstood what that line did. Okay, so we're going to do this. State, and I'm going to say state zb dot method equals, and I should probably call this method, not mode. And can I make this, first I need to export platform equals ps2 make. Cool. Control reaches end of non-void function. That's okay. We just need to return 1. I think 1's okay. One is happy. Cool. Beautiful. And that might be it. That might be what we need to do. So let's test it out. Let's copy this into our other project and test it out. We're going to go into side scroller test. We're going to copy library. We're going to put it in source lib because that's where it goes. And nothing should change. We expect everything to look the same. Cool. Now the challenge is, can we use that API? That's not the vi I want to have open. Can we use this API? Let's put it in main. Let's just say gs. Oh, hold on. I need to update my header as well. I need a better way to vendor these, but this does the job for now. P2G source include P2G gs.h. This goes into source include P2G gs.h. Okay. Cool. Yeah, we have set z-test now. Was I saying z-test before? Maybe. And the mode is going to be, we're going to borrow this from, well, I mean, never. Are these numbers not given? They are. Cool, so 2. Let's try setting this to 2, which is greater equal. And now if I compile and run this, we should get the corruption we saw previously. And we do. So there's a magic square on the screen here, and here, that nukes everything that it touches. This is conveniently roughly the same size as my tile set, just rotated 90 degrees, I think. I won't hunt that down now, but we should be able to do this. And so then if I set z-test to 0, disabled, well not disabled, enabled but everything enabled but everything fails. I want enabled but everything passes, which is 1. Sorry, yeah, always. So, I mean, if nothing ever passes the Z test, nothing ever gets drawn. This one, we don't do any Z test, and there's no corruption on the screen. Excellent, that's what we want to see. So this function is just so important for testing this sensibly. Otherwise, we have to recompile the whole library every time. And just to set one magic value in a static configuration blob, it's just a little silly. It's just a little bit silly. Okay, so when this is 2, so we want to be able to set this to 2, and we want to know why. We want to know why this ZBuffer, which is allocated like this, which should be okay. Actually, do you know what's interesting? I don't know if our VRAM allocator is going to handle this size properly, and this is in our core library as well. So let's open another editor. So this is in gs.c as well, I think. VRAM, is it? Frame buffer size, yeah. 16. Okay, so this is okay. So we, PSM, Z, So we're not calculating the frame buffer as the right size. We're not allocating enough space for this ZBuffer, because this function, gs frame buffer size, it's supposed to work out how big the frame buffer is, right? So if the frame buffer format is PSM32, we do the right thing. If it's PSM-Z32, we do the right thing, right? 32 bits, 4 bytes per pixel, we multiply the width and the height by 4. 24 bits per pixel, we do the right thing. PSM16 and PSM16S we handle correctly. PSM-Z16 we handle correctly. PSM-Z16S is unhandled, so nothing gets multiplied. So we probably want some kind of like default down here maybe, but for now let's just blindly PSM-Z16S. Let's blindly walk into the same error happening again. Export. Excellent. Okay. We're going to redo this copy. And let's see if this just fixes it. Exhaustiveness testing, yeah. The fact that I use a full through to handle the default case here, where it's only where it's like 1 byte per pixel, has bitten me. It's not ideal. It's not ideal. Okay, so if I go in and I set the the Z test to 2 and re-enable the Z test, this should now work. This should now look okay. And we still have corruption, but it's moved. It's moved to a different spot. So that's good. That's good. That's good. It's still not quite big enough. So how big should this be? How big should this thing be? So this should be, my frame buffer is 640 by 448 by 2. So it should be hex 5734408 8C000. Okay. So this is its size. This is its size in bytes. This is how big this should be. This is how big it should be. 3440. So that might be correct. If I re-enable trace logging, it'll tell me. It'll just also run so slowly that I can't really do anything, but that's okay. Head after frame buffer allocations. Let's look for that. So let's run, and then we'll run.log. This is gonna spam a lot of stuff. Okay, so VRAM alloc 286720. That's too big. 6 640 by... Still not being multiplied by 2. That's still too small. That's still too small. 8C000. Yeah, that number does seem to keep cropping up. And I guess that's just because it's some like fraction of the... Oh, yeah, because that's where our texture was being allocated before. What the hell? That's... Oh, I don't know why that's quite the case. I think that's literally a coincidence, but also maybe it isn't. You know, sometimes it's like that in programming. Man. Also, in my stream preview, this t-shirt looks like very black. It looks like I'm like the void, like perhaps too dark. Is that the case? Is it too much of a contrast with my extremely pasty skin? I don't know if this light is doing me any favors or not, but I've actually got the light on today, which is nice. Somewhat void-like. I'll have to keep that in mind. I'm not gonna like change right now, but I think for next stream. At least I don't have... If I had my long hair still, it would all just like merge into one amorphous blob. That's not ideal. Okay, so. Why is this wrong? 573440. Hold on. 573440. Huh? Isn't this too small? Shouldn't we be allocating 640 by 448 by 4? Shouldn't we be allocating 1146880 bytes for the... What? Huh? This doesn't feel right. This doesn't feel right at all. GS frame buffer size, GS PSM 30. Okay. Let's go back over here. Let's go back over to this thing we were editing. I think we need to trace log the size. GS D width, height, PSM, size. I think I should start using capital X when I print out hex number strings. And I think I want to go through and do a pass of this code where I change all my trace logging to do it like this. And also I probably... Let's do size divided by 4. Let's also print it out in words, because I think at some point I'm going to change all my logging to use words as well. For VRAM, the language of the graphic synthesizer is in words. It doesn't really refer to anything in bytes. So I think words make more sense. PCSX2 does as well. Refraction PCSX2's brain works in terms of words. So if he's going to come and help me debug, I should probably do the courtesy of changing everything to words. Okay, so why does this misbehave? For there are other 4 modes that I need to handle here as well. There's like 4H and 4... Isn't there a 4H for PSM 4? PSM CT4. PSM T4. I think there's other formats that I've missed. Because, yeah, what about PSM T4HH and HL, where they're kind of PSM T8 and PSM T8H, where it's like the upper bit in a 24-bit per pixel thing. I've not done my due diligence here. Okay, so anyway, let's copy this across. And let's run again and dump all this into the trace log, except this time we're going to get extra logging. So run log VRAM alloc. And maybe this wasn't compiled. Dlog trace. There it is. There it is. There it goes. Oh, hold on. That probably... I probably need to make clean here. Because the library updated, it doesn't necessarily know to recompile the function, the files that call that library. I don't know. That's probably the case. I probably don't need to recopy the library after a clean rebuild. It's probably fine now. Run.log. Still didn't do it. Weird. VRM alloc, vrm.c. Oh, it's frame buffers. VRM alloc. We call this first, so this should really. Okay, let's copy it in. Let's copy it in again. Get in here. Lib should be done. We'll do another clean rebuild, and let's see. It looks like it should have tracing enabled. What the hell? Why isn't it trace logging? Because it has trace log. It's compiled with trace logging enabled. I can literally see it. Wait, is it? The final thing is GCC link file. It all gets compiled together. But yeah, the individual bits, the individual files, log trace. Weird. Log.h log trace. Yeah, okay. How mysterious. What I'm going to do instead is just log dbg, right? If in doubt, just debug log it instead. I guess that works. I guess that makes sense. Okay, so then we want to look at run.log VRAM. And it still hasn't printed it. Huh. Okay, well this is like a different level of weird. Where's bind buffer, draw clear buffer? So there's other things, right? This is inside my library. This is library code. This is game code. Where's this gone? Where's this going? Unless, am I calling a different copy of GS frame buffer size? No? What? Huh? I hate this stuff, man. I hate when this just like isn't obvious, because it should be. It really should be. 640 by, oh, hold on. I can't math. I forgot I'm doing half height. 640 by 224 by 2 is this number, and by 4 is this. So they're correct. I want a wild goose chase. I'm still not sure why this wasn't logging, but that's okay. We'll just get rid of it. We fixed this. This is now more correct than it used to be. Okay, so why doesn't it still work? These sizes are correct. This size is correct. Run.log alloc 286720, 286720. And the head ends up here. Am I sure VRAM was in that log message in the first place? No, but it should be interspersed with these. It's definitely being called, like that function is what gives us this size. So it's just calling something, I don't know. But basically this thing was half the size it should have been. That was our problem. So now our frame buffer, our VRAM head after frame buffer allocations 1433600 hex 1433600 15E1000. So let's actually go back into main and let's practice what I was preaching. Let's go x VRAM head divided by 4, because everything gets divided by 4. ZBuffer gets divided by 4, everything gets divided by 4. Cool. frame head after frame buffer allocations. That for some reason. Oh, hold on. I worked out why the log wasn't updating. I wasn't actually piping it to the log. Someone watching this in the future is going to be really angry about that. And to that person, I'm sorry. There it is. There's the log message. Ah, maddening. Actually maddening. Cool. I love that. That's great. You can tell it's been one of those days. Oh boy. Oh boy. Cool. Now this looks like a different number, but it's actually just the hex version of it. 15E1000. Now. Okay, so there's something interesting here. There's something interesting here. I guess these are divided, right? I guess these are after they're divided by 4. It is. They're after they're divided by 4. So what I would really like in gs.c, when I log these fields, to do them in hex. To do them in hex. Hex would be better. Hex would be better. Everything should be hex. Everything should be hex. And one in words as well. Head divided by 4. Okay, cool. So let's copy this back in if I can find the line, and then rerun updating the logs. Very critically updating the logs. Run log. Cool. Okay, that looks a lot better. That looks a lot better. 23, 4600. So these are being, we're passing in the right values. We're passing in the values we expect. And that's good. 4600. That's big. That's a big one. Cool. So this is the motion engine heap. That's fine. But this we probably actually want to log the correct stuff. So I mean, well, I guess we get it here. Theorem alloc 2B00. And this says 158. So level bump allocator. So we allocate something here, which is good. It's right after it, but that should be okay. We have a big alignment. So again, that feels good. That feels good. Okay, so here's the next thing we do. We go into favorite directory where we dump all of our drawing information. So let's pick a random frame. Let's check what these frames look like. I'm not sure what this, I'm still not totally sure why this one's so little. This feels weird. Okay, so this is because we were filling the background with stuff. I thought I stopped doing that, but maybe I'm still doing that. Maybe this is leftover. Hold on. Didn't I stop doing that? I did. I stopped loading this thing and doing that. So I don't know why that's still happening. That's weird. It's weird. How does that happen? Okay. Mysterious. Here's what I'm gonna actually do. Delete all these files. Delete them all. Now we're going to run again, and we're just going to let it run for a sec. Going to make sure we get all 100 draws. It's going to take a really long time because we log all this garbage. These are all the bits being sent to the GPU, and there's a lot of them because all these tiles are rendered individually. Okay, so by now it should have done enough. Cool, excellent. So let's have a look at all these PNGs. So there's a bunch of black. It's kind of weird. I don't know why there's so much black. Also, this has like a gap in it. Okay, this is kind of weird. What's going on here? And it goes back to like empty. There's something strange going on here, right? Because this gap isn't actually rendered when we look at it. Oh wait, no, it is. It is, because we're still overriding part of... No, there is a gap there. This is like where our texture is now overriding. Okay, that's fine, that's fine. So let's pick a frame like this. I guess that's good. Draw 50. So let's have a look. 50 con... 40 context, I guess. And we can see the ZBuffer is at 1180. So this is where the frame buffer is. The ZBuffer is at 1180. Okay, 1180. So, and it takes the same width as the frame buffer. It uses this part of the register. Okay. Oh, okay. So the goal is to work out why this is overriding. So times 32. So this has been divided by 32. So let's have a think. Let's have a big think. So it says it's at hex 1180. Okay. And we need to multiply this by 32. So this and this left shift by 5, which is the same as multiplying by 32, is going to be, it's going to be 11800 left shift 1, which I can't do in my head. So we're going to go to Python 11, and we're going to get this as a hex number. That makes sense. That makes sense. 23000. Okay, 2300. So this is the word address for our ZBuffer. Left shift by something. There's a register called ZBuff here. And this says that the ZBuffer is the ZBuffer base pointer word address divided by 2048. So actually we need to multiply this by another 2048 to get the word address. This is too big to be a word address. What's this? $8C000. That's different again. Okay, so maybe we're not setting this register correctly. What are we supposed to be setting it to? What are we supposed to be? Where's this supposed to be? 460. The word address should be this. So what we expect is 460,000. So want 460,000. Sorry, that was one too many O's. Hex. Let's put a little X here so we know. So 46,000-ish hex. You know, 1,000. As 1,000 as you can be in hex. Okay. Nice. We got this. So let's say Z is 46000, and then we want to say Z divided by 2048 in hex. We'll use 2 divides. Word address divided by 2048. So this should be 8C, but that doesn't feel right either. Because frame buffer's at 8CO. There's like, oh, times 32. So it's the bigger version of this number? Okay, sorry. This is actually correct then. So times 32 means times 32, not... It doesn't mean multiply by 32 to get back to the correct number. It means we're actually multiplying this by 32. Okay, that's fine. That's actually good. That means that the ZBuffer is being set correctly. So from the word address here, so let's just say tick. Wrong way. We'll delete this. Let's say tick. This is correct. Excellent. So then I'm also just going to grab from off camera the first texture we allocate, which is 15E000. So hex 15E000. And actually the word address is 5, because we're going to stay in word address land, 57800. Okay. How big is this thing in words? How big is this thing in words? In words, it's going to be 286720. So it's going to be, the size in bytes is 286720, which is 640 by 224 by 2. So the size in words is going to be this divided by 4, 286720 divided by 4, 286720 divided by 4. That's also actually kind of, it's actually this divided by 2, I guess. As a hex number, 286720 divided by 4, 11800. That's weird. So the size in words is 11800. So we would expect this to go to, like this doesn't end until 6 plus 8 is 14. Hold on, 14. That's okay. That doesn't roll over a place in hex. 15D800. And this texture, this first texture comes in at 57800, which is too soon by approximately hex 100,000, which is a really big number. Words. Is that too big of a number? Does that even make sense? 11800, 27620. I guess the thing is, right? If this is a number of words that starts with 1... Oh no, hold on, I added a 0. 1, 2, 3, 4, 5. There's only 5 digits here. My mistake. So it'll be 57800, which is exactly where this starts. So it shouldn't overlap. What if I just put a little bit of padding in? What if I just like re-add like the tiniest little hint of padding to my main function? What if I just come back in here and I'm like VRAM pad VRAM? What if I just add like 1,000 hex words, maybe? And I want to turn trace locking off. Trace locking can absolutely get fucked. It's too noisy. It's insanely noisy. Okay, so does this fix the corruption? No, but it moves it even more. How much do I need to move it? This is the other question, right? What's the first address what's the first padding I need where I can no longer see it? So 9, I'm going to do a bit of a binary search. I'm going to find a number that's big that gets rid of it. 1. What if I go FF 1000? That should be big enough to totally get rid of it. Put it somewhere else in VRAM. Yeah, okay, FF 1000. It's gone. It's out of here. Nice. So what about 88,000, which is like halfway closer? Okay, we're gonna binary search this. 88,000, not visible. Not visible at all. So it's gonna kind of appear over in this corner, right? 8,000. What if I try 22,000? I've broken my binary. Well, no, I guess not my binary search. I didn't halve it. Okay, so that's okay. So what about 11,000? I'm not doing this right. That's okay. But 11,000, it has appeared. So somewhere between 11,000 and 22,000. So what if we try 1F,000? This isn't very scientific, but it kind of makes sense, right? We want to find where this thing originates. So there, we can't see it. So what about 24,000? And I'm saying these numbers weird because they're hexadecimal numbers, right? So 28,000. Didn't I say 22,000 it was visible? Didn't I say at 22,000 I could see it? Wasn't that what I was doing? Or was it 4? Wait. Huh? Oh no, it was at 1. Sorry, I went the wrong way. At 1,000 it was visible. I went backwards. I got lost. 1,000 it's visible. I was getting bigger. I need to get smaller. So 14,000 hex. I got to specify that it's hex. Otherwise, how will I know? Okay, so not here. So 12,000. So the padding's going to get smaller. Then at some point it's going to overlap again. So here we're fine. But at 1,000 it appears again. So I want 1,500. Here we go. Once I know exactly what I'm off by, that's going to really give me an important bit of information. Okay, so no corruption here. So let's... And 500 was the wrong thing. I should have done 800 because we're in hex, but that's okay. Let's go to 2. Right, I just want to see the tiniest little hint of corruption in this corner. I want to see this bad boy not draw. 1. 1? Measly little 1? No, nothing? No corruption? Okay, what if we go to 08? And this is good because these are words. Here we go. Okay, so now we have something. Now we have a little bit of corruption. So we want to get a little bit bigger again. So let's maybe try 10E. 10E. No corruption. So let's go to 10D. This is extremely manual, but that's okay. Oh gosh, my hair is... I wore hats today, so my hair's a bit all over the place. D? No. A? This is the worst binary search ever. Binary searches don't work if you get lost and start going the other way at some point. B? It would be like B8 or something, right? B, we can see it. So, but C, I'm going to guess we can't. Oh no, C, we still see it. But D, no dice. It's gone. And partly this is because how much I'm padding it as well. Let's go C8. What's the lowest number I can put here that still shows corruption? Or what's the lowest number that shows no corruption, actually? That's what I want. C4. Humans bad at binary. True. True facts. So it's, I think it's actually C1000. That's the lowest. What if I go into wait, which task set do I load first? I load edge first. Kind of weird. Entry. What if I don't allocate this? What if I don't align this as aggressively? I shouldn't need to align this so aggressively. There we go. Okay, so that's better. That's better because it gives me a more precise number to work with. So let's go back to EO. Okay, here we go. So now we're gonna be able to, let's try 12,000 again. Okay. Should have changed that first. That's okay. 10,080. Yeah, because one CO was visible. So this is, it's, corruption's visible here. Corruption's visible here. What about at D? O. At some point we just tick over and the alignment pops it out to the other side. E, O. And you can kind of see like this, it's actually not moving as we change this number. It's still aligned to a certain spot, F, O. Maybe it is just, maybe it is 2. FF. Like this literally won't, oh wait, hold on, there's a whole number here. There's a whole digit that I'm not dealing with. 8. My mistake. That's the digit. I was changing the wrong digit. Numbers are hard. Numbers are hard. That got worse. Huh? As this gets bigger, it should get pushed further down. As this gets bigger, it should get pushed further away. Actually, you know, there's a really easy way to... Ah, now that's different. Now there's a gap. That's funky. But that's probably just block... Actually, I can't explain that. Okay, so I'm pretty sure that means that... I mean, we can try like F1 F1000, but I'm pretty sure... Yeah. Okay, so basically... The boundaries around here. Once we get to 1-2,000, we've padded enough. Oh no, 1, okay. I'm glad I did that one extra test, because it's this. This is going to be, short of playing with the alignment of the texture even more, 11FFO. This is how small, this is how much we're off by. This is how much bigger our frame buffer seems to actually be. So let's write this number down, because this is an important finding. So we think the size should be in hex. No, that's okay. We don't need in hex. Let's say error equals 11FFO hex 11FFO. Okay, now let's divide that number by 4. 11FFO divided by 4. 47FC. In words. Let's make that C look more like a C. Let's make it look less like an O in words. 47FC. So the width, according to this, should be 1, 5, F, F, C. Sorry for mixing case in my hex. That's okay. In words, 15FFC instead of 11800, which is a weird number. It's a really weird number. It's a bafflingly weird number, in fact. I don't understand where this number is really coming from. Because so. So if I just so what's the hex representation of this? 286720. So let's call this ZS. Let's say the size is 46000. And the size in words is, wait, 1768. Where did this come from? Where did this come from? Where did I get 11800 from? Oh, that's not hex. God. I wish there was a way to 1180. Yep. Ah. Gosh, it's always alarming when you get a very weird. The Twitch spam bots are getting so weird. Like, I don't know. Is this normal? Does everyone get these spam bots? Esports betting. It's like some weird SEO stuff. It's so strange. So strange. Cannot work it out. God, I've had a really weird day in general today, actually. I talked to an old man on the tram, and he told me about the first Australian Football League grand final he ever attended, which was in the year 1949. TK Dev, welcome. Hello. Thank you for confirming it's not just me going crazy. What was I doing? 11800. Did I control D? I did. I was building up some state in Python and I just control D. That's okay. So did these bots appear only in the post LLM world? They must, right? That this feels, but it doesn't really feel like, it feels too weird to be an LLM unless it's a weird quantized crunched LLM with no, I don't know. It's strange. It's strange. I don't know who writes these things. And maybe I'm doing a disservice by even addressing them. Maybe you're supposed to just ignore them, but like it's just, there's something so unsettling about it, right? Something so unsettling about it. So what is the difference between these two numbers? Okay, other than, you know, obviously the actual mathematical difference, why should we get one of these numbers and not the other? Actually, I'm going to go back to Python. So if I say ZS words, and let's do this manually, 11800, and let's say ZX words for the one that I don't quite understand, which we'll say is 15FFC. Okay, and we'll just do a quick hex, ZX words minus ZS 47FC. Excellent. I can do my hex. I can do my hex sums. Message is pretty much always the same, just different account. Bot messages like that long before LLMs were a thing. Yeah. This is true. That's just it feels like AI generated in some form, but yeah, who knows? Always the same, different account. Weird. I'll take the free follow. Thanks, Spambot. Follower, you know, he's in my history books now. Oh, I was getting my hair cut the other day, and the barber was like, "Man, that's a big water bottle." And I was like, "Yeah." Oh. Why PS2? Because it's a nightmare. It's a really weird, complicated system. It's very hard to tame, and I'm having a lot of fun taming it, even though there's lots of weird quirks. Like, I don't know, OpenGL is fun. OpenGL is really cool. But sometimes you're like, I want to understand VRAM. I want to control, you know, everything. And writing really low-level code for modern GPUs is hard. There's a lot of differences between them. So having a platform like the PlayStation 2 where it's like, okay, here's exactly how everything works. Here's a 176 page book that documents 176 page book that documents everything about the system. Just ignore the copyright, don't look at that. Yeah, it's cool, and it's cool to hear you like the PS2 as well. So, you know, it's a painful journey. We're all on this train together. I'm very happy whenever people want to hang out. Ignore that it says copyright Sony 2000. Oh, I see what you're doing. Sometimes I miss the joke. So hold on. 11FFO divided by 4. Yeah. That's how I got here. The reason awesome, cool to see my new emote coming out. Glad you're enjoying it. X-Links. The reason I missed this joke is that the PS2 dev community, not on the whole, PS2 SDK is really well done, but there are certain people, especially in the reverse engineering scene, that play so fast and loose. Like, okay, hold on. Let me show you a repo. This is a sidetrack, but I'm gonna do it. Let me see if I can find it. Hold on. It's in my messages somewhere. Who sent me this? Who is that person? Okay. Yeah, this one. So this is a repo This is a repo where people are reverse engineering Kingdom Hearts 1, which is really cool. But you go into Tools, and you go into CC, and this is the entire Sony Emotion Engine toolchain. They've got all their headers too. So like in source, in include, they've got the entire copyright. So like all these files, I'm pretty sure say Sony Computer Entertainment Confidential. They've committed them to their repo. And I'm like, hey, you know, maybe don't do that. I don't know. You're gonna get DMA. You're gonna get DCMA'd at some point. Well, maybe not, but you could. Smart community. Yeah, it's building a community that could disappear overnight, right? And I've told them, I've expressed my concerns. They're not. Maybe not with these people in particular, but with a few people doing similar stuff, and they're like, "Oh, there's no other way." I'm like, "There is. You could do like if you look at emulators, if you look at PCSX2, PCSX2 still exists because they don't distribute the PlayStation 2 BIOS. They make people go and find it themselves, and download the copyright bit themselves. With reverse engineering, it's harder because you need the exact toolchain versions that game used if you want to get like a one-to-one thing. So I understand it, but share that stuff in private if you're going to do it, and don't do it. Sony probably doesn't care. Exactly. But if they decide they care, they can come after your repos and they'll disappear. Look at what happened with the Switch emulators, right? They're gone. They're gone. Whole communities, poof, they're gone. So you're always playing a risk. It's always a risk. If Sony decides they care, and they could, they don't care until it's big. Yeah. Nintendo, yeah. You don't care until it's big. Not even necessarily. Like, Nintendo have gone after some really small players just for kind of existing. Like YouTubers uploading videos of stuff. There are forks. The problem is there's no longer like... I don't know if there's any central organization. The people who were doing that dev now are no longer doing it because they're scared of getting sued. So there are forks of those emulators, but... it's hard to really verify who's doing builds and who's made changes, and like once that central organization is broken, you can really have opportunistic people swoop in who want to like install malware on people's computers. So I know there are definitely like people have found builds of it with malware bundled on different sites. It makes it a lot harder to trust, right? Ultimately, with any open source project, there is trust, but now the core developers who we trusted have been broken up and they've gone different ways, and as far as I know, are not working on it anymore because they're the people that were in Nintendo's crosshairs and they don't want to get embroiled in a legal battle that they'll probably lose. Especially, I think the Yuzu devs were like sharing files in Discord that allegedly that they shouldn't have. So if that all came out, like they're just done, right? It's a pretty severe penalty. So, and that's another example, right? Be careful with how you build your community. Don't share stupid shit, even if it's, even if it makes things convenient. Anyway, that's a really big sidetrack. This isn't a podcast. Well, it is. It's my personal podcast, where I talk about whatever I want. Okay. So what I really want is some kind of mathematical expression that explains where this number comes from, right? Because this number is derived from the actual resolution of the screen. So how do I get an extra this much? And actually, what's probably interesting to do as well, 111FFO, 73,712. 73,712. That's a very specific number. Okay, so 73,712. I don't know. 73,712. TK Dev, thank you so much for the follow, by the way. Welcome. And yeah, it's cool. Sorry, we kind of got a bit lost there. GitHub's going to remove stuff. Yeah. We got a bit lost there, but you did a little bit of PS2 dev. You moved a rectangle around. So was that using PS2 Linux? Was that like using PS2 SDK? What was that in? How did you do it? Because I know there have been different things over the years, and PS2 Linux was a really cool way for a lot of people to do it back in the day. I know there were universities that actually taught using PS2 Linux, bit of graphics, bit of stuff like that. DevKit Pro. I don't think I've heard of that one. What is this? Root color into VRAM, yeah. Yeah. I mean, that's a valid way to do it, right? That's pretty cool as well. You can just upload stuff, and that's kind of what I'm doing right now, except I'm just happening to upload my textures into the ZBuffer, and I don't know why. I don't know why. So, So 640 by 224 by 2. This is the size of the ZBuffer. What if I multiply by... But if I multiply by 4, I get something way too big. Way too big. I'm looking to add 70,000 to this. So where does 70,000 come from? What if I change this to 324? Also way too big. I'm going to change it to 244. Not quite big enough. You see what I'm kind of trying to do? Like, what... What is my ZBuffer actually representing? If it's not 640 by 224 by 2, how tall is it actually? You know? And actually, maybe it's worth quickly revising my understanding of the docs, because I think ZBuffer... I might be looking... Coordinate system of the ZBuffer, right? Where does the ZBuffer get its height? Because it gets its width from the frame buffer width. And the frame buffer, I don't know if it explicitly sets a height. We'll find out. So Z values of pixels are stored as a drawing. Starting address. Specified in the ZBP fields. ZBuffer is 2048 words. Address divided by 2048. Except it's not the address, it's the word address. Graphic synthesizer works in word addresses. So if you're thinking about byte addresses, you have to multiply this by an extra 4. You get what? 90, 91, whatever. Coordinate system same as that of the frame buffer. That's good. ZBuffer formats. This was this thing that I got wrong before. Both have to be from group 1 or group 2. Messed that up for a little while. Texture buffer. Okay, that was it. That was everything. That's the whole frame buffer section. Frame buffer. Oops. Frame buffer. Size of the frame buffer. Frame buffer width, multiple of 64 pixels, FBW. Height is arbitrary, not specifically set. Scissoring functions. So, but that doesn't make sense either, because this I must be setting the scissoring area correctly, because it's correct for, well, actually, is it correct for the frame buffer? Because my aspect ratio is wrong, right? Like if we look, this is supposed to be 640 by 480, or 640 by 448, and it kind of gets that, but my squares aren't square. My squares aren't square. Maybe that's actually, I don't know. I feel like something weird might be going on here. And I can actually check my scissoring functions. It's in these vsync files. So let's look at vsync 00050. Scissor? No, scissor is in the context files. Context. And I don't really know how they work. Did it say width is a multiple of 64 pixels? Yep, and my width is 640, so that is fine. My width is actually 10, but that's 10 times 64, which is 640. So that's why it's a multiple of 64, because this register, like it has to be, this register is interpreted as the width divided by 64. Coordinate system. Primitive coordinate system in window, coordinate system drawing space, use to set vertex coordinates, x, y coordinates, fixed point 16, 12.4, 93. That's why we see that subtraction. Okay, that's something I've seen in PS2 SDK a few times that makes sense now. Window coordinate system. X, Y offset. This is all, I'm pretty sure this is all okay. This all feels okay. Scissoring test. Text, coordinate values, pixel to be drawn in a rectangular area. Judged by the following formulas, scissor, sca, xo. So if it's less than this or bigger than this, less than this, bigger than this, 223. 223. So this is our size -1 in the scissor registers. I don't know why it's -1, but it's -1. I think we can do with that. Then this gets into alpha stuff, which isn't relevant. So I could keep this magic line here, right? And I could keep going, and this would work. And I would never work out why my ZBuffer is the wrong size, but we could keep going. It's just so annoying. It's such a weird size, right? Because everything looks fine. Everything looks good. Do I just have this weird magic hack value in here? It's a non-trivial amount of pixels. That's the only thing. A non-trivial amount of bytes. I mean, it's an extra... It's literally an extra 70,000 bytes. $70 kilobytes. How am I 70 kilobytes off? It's completely unfathomable to me that I could be calculating the size so incorrectly, right? I feel like I just read everything about the ZBuffer. Use frame buffer, 2-port. Frame ZBuffer port is independent of the texture port. Local memory. Memory has right point. Everything is aligned. Yes, yeah, and that is correct. And even if it was off, I don't understand how. Like, if I'm 1 off, I don't understand where the 70,000 comes from, right? Or the 47F. Oh no, but this is in. Yeah. So wait. 47FC. Sorry, hold on. Wait. That 47FC. 47FC. 18 kilobytes. My mistake. So even if I'm off, 18, wait. Yeah, it's still like half, like it's still more than double the size of the alignment that this thing is wrong by. So it's only 18 kilobytes. Okay, that's 18 kilowords. Kilobytes, kilowords. 18 kilowords. It's confusing. I need to start doing everything in words. It's going to be a lot clearer once I do that. But area for drawing, address value. So this is what I want. So okay. Why is there a gap here? Why is there a gap here? 32-bit word units, yeah. Frame buffer starting address, ZBuffer starting address. 2K words. This is all good. Starting address buffer is specified, unit of address divided by the above alignment side. Yes. I feel like this is the section that's going to tell me what I need. Maybe I just hard code this gap. Maybe that's there for a reason. I don't know. Starting as the buffer width, XY coordinate buffer, one-dimensional, converting from two-dimensional coordinates. The graphics on special processing. This is fine. And now we're just back into this stuff. That's the only annoying thing. Each thing is 2 words. No, it's each thing's half a word in size. So it's 2. You get. It's just so weird. But that makes sense because. Okay. This is. I don't know. I don't know why this gap is here. Like, I fixed it. I can keep going. It just is shit because it shouldn't be there, and I can't see why. I can't see what I've done. The numbers look correct, you know. So maybe I just roll with this. Maybe I just keep going with this. Maybe this is a good enough starting point. And I have this weird hard-coded number and I need to do more digging later. But maybe this is fine. Maybe this is okay. Oh, it's still annoying. Floor. What I do need to do, however, is get rid of this garbage so that it looks a bit less shit. Test, test, load. I'm just gonna, just this little random background fill isn't really necessary with my shitty tiles. You can also see that like some of the edges of these tiles are only selectively drawn depending on where the camera is, which is a bit weird. That's another bug I need to work out. It's just an oddly specific number to be off by, you know, that's like, I'm gonna wake up at 3 AM tonight and be like, why that number? Why is it off by that much? But anyway, oh wait. It's not fixed. It's not, this is still in the corruption zone. Look at this. Where's this guy hiding? What's this guy doing? Where did he come from? Okay, so there's still this corruption block. And the fact that it's non-contiguous now is really, really concerning. Like, extremely concerning. Like I don't know what's going on anymore concerning. I'm gonna move my thing to, my offset to 1,2,000. And let's just move around a bit and make sure. And I think we do need to just do some of this like random moving around to really see. So maybe it, okay. See, that's a nicer number, right? That's a nicer number. So 1, 2, and conveniently, that's just hex 1200, which would mean that, hold on, let me go back to this. So 12000 bytes, which would be 1200 words, because we're right shifting by 4, which is easy to do in hex, thankfully. So 1200. So what is, so 11800. 1200. That gives us 12A00, which looks like a nicer number. Words. 12A00 words. So 286,720, 286,720 minus, oh, wrong order, wrong way around. Also also focus. Minus 286,720, 18,432. Now, that's interesting. So, hold on, 1024. Okay. So, this number's a multiple of 2 to the 11. I don't know how significant that is. Prof Elements, hello. I'm working out why my textures, my textures were overlapping my textures were overlapping my ZBuffer, and I'm trying to move them around. So I put a buffer in place, like I put some padding in place between my ZBuffer and the start of my textures. I've manually put this padding in, and that has gotten rid of it. This is the smallest number that seems to work. And now I'm just trying to work out what this number is, where this number comes from. Why do we need this padding? Why is my ZBuffer too small? Because when I do the numbers by hand, I agree with my code. And that's really not good, because like my code my code's not incorrect. My code matches my understanding. So my understanding's wrong, and that's really hard to work out. It's really hard to work out. Hold on, was I doing that with the wrong number? I was doing that with the wrong number, wasn't I? No, that's the difference, the difference. So that's the... So this is the start. No, that's the... Hold on. What I did there didn't make sense. What I did there didn't make sense. Yeah, so that should just be... Except I didn't mean to hex that. 406. So this should be the size, and then we have this padding. 286,720, 286,720 divided by 4. This is 1180. That's this thing. The difference between 16 and 16s in that code, there's a table of modes that are compatible, and the mode that's compatible, so 16 and 16s have the same pixel format, but they're interpreted slightly differently. You have to use 16s when you have a 32-bit when you have a frame buffer in any mode except some weird legacy 24-bit per pixel mode, I think, or like 16-bit per pixel. I can't remember the exact mode that it conflicts with, but basically there's one frame buffer mode where you use 16, and then every other normal frame buffer mode you have to use 16s. It's just a rule of the graphics synthesizer that I don't fully understand, but yeah, just in the docs there's a table that says what you're allowed to use, but they have the same pixel format as far as we're concerned. Handled maybe a little bit differently, maybe by a different part of the hardware, but same pixel format. Okay. So this isn't right anymore. Neither's this. Error is now 12000, which is easy to convert to. Oh wait, no, hold on. Right shift 2. Hold on. That was all wrong. That was all wrong. 12000 divided by 4. That's a different number. But that is the difference that I worked out. 48000. 4800 in words. Because the graphic synthesizer works in words. We're trying to do more of our work in words. 48000. So 11800. This would be 1516000. Because 8 plus 8 is 16. Huh. This is a disgustingly round number. So 640 by 224 times 0.5. Let's actually divide by 2. Is 11800. 16000. So it's like having a wider frame buffer, right? Or actually, it's like having a Tula buffer, a Tula Z buffer. It's like saying our Z buffer is 100. It's like saying our Z buffer is 280 pixels high instead of 224. That's the difference. So why is it too big? Because our graphics mode looks okay. Our graphics mode looks fine. Our graphics mode says 640 by 224, but it's still stretched weirdly. So maybe actually if we fix this, the Z buffer thing will be fixed. So maybe we need to look at our graphics mode again. Unfortunately. Okay. So, let's look at... What if I try and set it to like a normal 448? What happened when I did this? This made it like weird. This scaled things weirdly because you're not supposed to do this. Yeah. This put things in the wrong spot. And that makes sense. That makes sense. That makes sense because of things. Mode NTSC. So what if I do mode DTV 480p? I think this graph mode HD TV. What if I do like a proper 480p mode? Does that work? No, it's too wide. What? And also we do this weird... So why is this so weird? Why is this so wide? Can we only have a 224 high? Like, is this the right mode? Refraction, hello, welcome. What have I done? What have I done here? So I've given up on NTSC signal. 480p mode is 720 wide. Ah. Oh, and it has to be 480. My mistake. Huh. So you have to like clamp it in. I mean, it no longer, we've got this like outside the frame issue. Interesting. We don't appear to have any ZBuffer corruption though. That's because I moved it. What if I... That's not what I expected. What do I get rid of my padding? Are we going to have something drawn randomly in the middle of the screen? Or is this buffer size okay? See, maybe this buffer size is okay. So basically, the problem as it goes is, when I'm not doing silly stuff with digital TV modes, and I'm in 640 by 224, which should be 640 by 480 in effect. Wait, where'd it go? Where'd the... Huh? Oh, I added it back, yeah. So this basically, I worked out the offset that's wrong, right? So if I run it without this padding, I have this ZBuffer corruption, which disappears if I disable the Z test, this mysterious box. The smallest number that I can offset my VRAM by between my what I think the end of my ZBuffer is, and the start of my first texture is this magic number, and this is in bytes. So in words, it's 4800. If that sounds like a familiar size to you for some reason at all, 4800 words, right? Hex. And if I pad like that, so an extra, 4 kilowords, no corruption, we're fine. So my Z buffer, I'm not allocating enough space for my Z buffer, but when I do the numbers by hand, I get the same thing. This size is 640 by 224 by 2 divided by 4 to get a word size. 4800. 4800. That's the... Wait. That's not the ZBuffer address. That's the size of the ZBuffer. The ZBuffer address is hold on. Let me get it straight from the horse's mouth. 1180 times 32. So that looks fine, I think. And then my first texture comes in at... Oops. My first texture comes in at 1. I've started logging things in hex and in words just for you. 57800, right, as a word address. and this was before my padding. So with the padding, this is offset by, this would be 5B something. That's okay. You're fine. No, I appreciate any help you bring in. ZBP is 32 instead of 16. What do you mean, sorry? ZBP is 32 instead of 16. Do you mean this? This is just how PCSX2 chooses to output it. The format's fine. PSM is, I believe, fine. Let's double check the PSM's being set correctly. I mean, that can't hurt. That can't hurt. PSM Z16S hex 3A 58. Huh. PSM. Is this? Hold on. Wait. I want to check here. ZBuffer. ZBuffer 1. ZBuff 1. There it is. Oh no, sorry. This is a different bitmap. 16S, that's also not what? PSM. It should be 1010, which is 2 plus 4, which is not hex 32. That's for sure. It should just be. Does that make sense? Also, why is this window picked up as this thing? This doesn't go here. Why is that there? Go away. ZBuffer ends at 1A40. Okay, I'll take your word on that. But if Z16S looks correct to you, that's good. That should end 1A40. So 1. So, oh yeah, hold on. Sorry, I'm looking at the size. Let me do some math as well and see if I agree. So head. Oh no, that's my bump allocator. Sorry, alloc for 11800. So that is a 46000. And this is a address divided by 2048. Is it? Or is this a word address? Divide the height by 64, multiply it by 10, shift left 5, word address. But, But isn't that too small a number? Because okay, so our frame buffer, right, is 640 by 224 by 2. So in words, it's 46 kilowords in size, right? Oh yeah, but sorry, divide the height by 6. Yeah, you're doing a block address. Yeah, cool. So, frame buffer should be 448. Oh, that's right. We did this, didn't we? I've mixed my paradigms. This stuff, yeah. How many pages it is? Yeah. Okay. 70 pages, it's 7 tall. Buffer's 10 wide, yep. In other words, if I do that properly, we'll have no corruption. I'm using more VRAM than I need to, but we have no corruption. Okay, so the problem is so interlacing, and not even interlacing, because I'm not interlacing anymore. So why do I set, like, why is my height 224? Why is the video mode, like, why is this not, like, what? If I'm not interlacing, I shouldn't have 448 height. Isn't that the opposite? Oh no, yeah, okay, sorry. If I'm not interlacing, but if I am interlacing, if I'm interlacing, I basically would have one frame buffer that had a height of 448, right? And I would only render the alternating lines of it each frame or something like that. It removes, like, interlacing means I don't double buffer. Is that right? Is that wrong? It only reads alternating lines every time. I don't know. Interlacing is confusing. It turns out I'm in frame or field mode. I'm in frame mode. So that means that I read the whole thing every time and I want double buffering. But, oh man. So I want my final image to be 640 by 480 in some configuration frame. You want his full height buffer. So I'm in frame mode and I'm in non-interlaced. In other words, progressive scan. So my height, my frame buffer height and my screen height should be 448, right? I battled this recently, but this should be 448. But when I set it to 448, I get a weird mode. It doesn't understand. So let's get back to this gem. Let's, like, clear all this stuff out. Let's look at some of these registers again. Because I don't understand how I've got here. Because this looks like the right size. This looks like 640 by 480, right? But then when stuff starts drawing, the sizes are weird. But maybe that's just because of what you said about software mode. Then where I'm setting my mode. Yeah. Okay. So I guess this is a screen clear. I don't know what this is. And then drawn tiles. Because these look okay. Okay. So I guess I kind of want to look at... Let's maybe just jump to the middle. So my width is correct. A lot of this code I borrowed from PS2 SDK. But, like, probably half borrowed badly. Some of it's still just calling into PS2 SDK. Like, yeah, always good. Good artists borrow, great artists steal. This is a quote that I always love to reference, especially on these streams. But, like, I'm literally still calling draw setup environment draw primitive. I'm literally calling PS2 SDK functions for this. So that's interesting. I wonder if it's partly my height calculation being silly. PCS, yeah, so I want it, but I want it to be, well, what if I want it to be progressive, right? So if it's non-interlaced and like, can't I, because, yeah, what if I want it non-interlaced? What if I want a higher resolution signal? Yeah. But what if I want it progressive? What if like the NTSC progressive mode? Like, isn't that or is there a mode for, isn't non-interlaced progressive? Like, aren't they opposites in this context? 480p, oh, okay. 480p. So what do PlayStation 2 games do when you have them plugged in with component cables and you set progressive scan? Do they go into a 480p mode? Because the way I keep mixing these up. The way PS2 SDK has this set up, they went to 480p. So like what PS2 SDK has set up as the digital TV mode that's 720 pixels wide. Interesting. And then they, I guess, adjust the scissoring to cut off the outside so that it's like the correct aspect ratio or something, right? Or like mag V and mag H. I don't exactly know. I don't know how you would get a normal looking signal out of that. Okay. Well, let's stay in that. That is so different to how I thought it worked. So that's really good to know. So what if I go back to... So interlaced and frame? Or does that not make sense? Does it have to be interlaced and field? Does frame make sense if I'm not in a progressive mode? Let's go back to this. Yeah, almost every game, right? Because it's more work to support both, and you have to... Okay, you have to support both. I've used frame, it cheats and turns off interlacing. That makes sense. So in field mode, it kind of divides the height by 2, which I guess makes sense. But this is also not right. This is also not right. This picks up the numbers I gave it, but it doesn't... Yeah, 224 height. So what do I tell? Like, what parts of this do I tell to be... So do I tell... Hold on. And it's hard because I've got a third layer in here now. Because this... And PS2 SDK does extra logic based on the mode name, but I guess only if they're photo figure disable. In the eye. Mode interlace. Yeah. So I even from the hardware manuals, I haven't really been able to make sense of these modes. Initialize screen size. So screen size as in... Okay, so screen size is in... screen dimensions, and screen dimensions... This is... Hold on. So... Screen size... What do you mean by screen size, right? Because screen width macros, yep. Cool. So this is... So when I say this is like my frame buffer, right? That's what this actually is. Yeah. Oh, no, because this is in place now. Yep, okay, hold on. Sorry. I keep mixing it up. So now it's in the right mode, but I've got this offset. But back in my library code, we noticed that I had this weird... it's weird offset. I was subtracting plus width minus this. I was adding half the screen's width and height to things. So let's maybe stop doing that. Right? Have I got something doubling the height when interlacing? No. No, but I suspect this is actually my XY offset stuff that I was doing wrong, where I was subtracting instead of adding, because it's not like half the screen width. I want field mode. Yeah, okay. Okay. This is a very different size to what was being rendered before, but this now looks correct again. This now looks very correct. So it really was just the right combination of settings because I didn't understand what it meant. And I'm worried that, like, does double buffering still make sense with this setup? Is this the, because from my understanding of interlacing, we're only, I don't need to double buffer because, but in frame mode you do need to double buffer. Cool. So I'm better off not double buffering and letting the PS2 hardware handle that for me. So I can do that. I can do that. Okay, I can't do that easily, but well, I probably can. GSC flip. I do this swap. It makes sense to still have it. All right, I'll keep it because the code that does it is pretty clean. It's been working for like 3 years. I don't want to touch it. I don't want to mess around with that. So, because I guess you still have the potential timing issue. Okay, holy crap. So, I no longer have ZBuffer corruption. That's good. It was me. The problem was me. PS2 will be scanning down the frame as the next frame is being processed, so if I change stuff halfway, they'll be tearing. I don't like tearing. That's why I wrote it like this to begin with. That's why I did double buffering. It was not good. Now I just have to fix these weird texture boundary problems, but that I think I know how to do that. It's not great. Yeah, tearing is not good. When I first started doing this, yeah, I only had 1 frame buffer, and it really quickly became apparent what the limitations of that were once I started drawing lots of stuff. Like when everything I was drawing fit into one draw call, it was fine. Once I started doing stress tests and issuing a lot of draw calls per frame, suddenly 1 frame buffer became very evidently shit. Okay, so this is cool. This is cool. I think I might call it there. I'm going to go hardware verify this right now, because every time I say I'm going to do it right now, I never actually do, but this time I am. With the other mode, you can use 1 buffer, but every frame, you need to make a copy of every other field into another buffer. That sounds too complicated. That sounds way too complicated. Okay, I'm going to call it. I'm going to call it there. I'm going to play around with this off camera a little, but we've fixed our big graphical corruption gripes. We worked out what was going on. We worked out I was overriding the ZBuffer. The ZBuffer was bigger than I thought it was, bigger than I was allocating. We were allocating the wrong size of ZBuffer. Refraction says they're on Discord. Thank you so much. I appreciate it a lot. I do really enjoy doing this stuff live, and I hope people watching get something out of watching me do it live. I hope it's useful. I hope it's interesting. I hope people are learning. But yeah, holy crap, Refraction. I'm pretty sure, hold on. This one doesn't have a readme, but I'm pretty sure in the readme, no? I definitely put a thanks to you somewhere. It should be in this readme. Maybe it's in a different branch. I don't know. But I've definitely shouted you out somewhere for all the help you've given me and all this stuff. You're absolute master of random PS2 knowledge. I appreciate it so much. And I hope you're enjoying the journey, because oh boy, it's been fun. Okay, let's find someone fun to raid. Let's throw the party on. Let's find a cool weird channel doing good stuff. Okay, who's doing interesting stuff? Who's doing interesting stuff today? Always happy to take suggestions for people to raid. This is also usually the point where YouTube people jump off, so thank you very much to people who have been following along on YouTube. Refraction, thank you so much. Have a great day. Have a great day doing whatever you do. Bit of German, Godot. I do like Godot, but I don't speak German. Metroidvania in Unreal Engine, that's pretty cool. Overlay, New Horizons, that's a bit of stuff. Oh, hold on, I don't just have software and game dev on. I want a Doom speedrunner I follow came up, and I'm like, he's not. Why is Devo coding? Yo, good Bobbius, thanks for hanging out as always. Love having you here. I might just throw some people on to Program Alive. Very chill looking channel. Let's rate them. and always looks like a chill chat where people talk about random stuff. We've got a bit of a Pac-Man thing going on. It looks like fun, so let's go over and share them some love. Thank you so much, everyone who's been hanging out. I'll be sure to catch you all next time, and hopefully you'll be sure to catch me next time, because I'll be here. We're doing more PlayStation 2 stuff, and it'll get more interesting now that I've cleared this little technical hurdle. Thank you so much for tuning in. I'm Tom, and I'll see you next time. Bye.